I'm so excited to be here. This is my first ever DevOps Days ever, and it also happens to be in Philly, and I live here in Philly. Who's here from Philly? Yes. All right. So my name is Ross Kukulinski. I currently work at NodeSource as a product manager. I help out with the evangelism working group for the Node Foundation. I've been involved with Node for a long time now. I'm also a huge container enthusiast. I've been working with containers for a while now, both good and bad parts of containers. And I have an introduction to CoreOS video tutorial series by O'Reilly, and I'll get back to that. So a lot of my time I spend working with application developers. These are developers that are used to the world where they just write some code and throw it over the wall to the operations. And either higher up in the organization, they've been told, we're going to do DevOps. I hate it when I hear that, because it tells me that someone doesn't really know what's going on, but they know a buzzword. The buzzword is DevOps. But these developers, they're interested in getting more involved with the holistic application deployment lifecycle. And one of the things that probably people in this room comes as no surprise is that someone who's a full stack web developer isn't really as full stack as you need to be to do all the things necessary to be successful in a DevOps world. It's more than just HTML, CSS, JavaScript, and your server-side programming language of choice. And I find that when I start having this conversation with the developers, the management teams, that I sort of give them two options. They can take the blue pill and believe whatever they want in the la-la land of applications, or they can take the red pill and learn just how deep the rabbit hole goes in trying to understand and how to build out your applications. And that rabbit hole is quite deep. People here that are on the operations side of things, you know things like logging, distributed tracing, networking, network protocols, file systems, distributed file stores, gossip protocols, containers, VMs, Cloud Foundry, all these different things. And it's a lot to learn, especially if you're a developer that maybe is just getting started. If you're a beginning developer and you're suddenly thrown into this world where you're like, I just want to understand how JavaScript works, let alone now I have to be responsible for deploying my applications and understanding how to build out that infrastructure. But that's okay. There are a number of resources to help you learn. Angelina Fabro did an excellent talk at JSConf in 2013. It's on YouTube. It's got like 100,000 views. I highly recommend watching this video, especially if you're a beginning developer, or her talk is not just new developers, but also intermediate developers. How do you make the leap from, I'm an intermediate developer, how do I become an advanced, or how do I become an expert? When am I an expert? And some of the things that Angelina points out are things that I think are important as a lifelong learner. So that's things like ask why obsessively. Just why? Why are we doing it this way? Why aren't we doing it this other way? Teach or speak at an event. I'm here, trying to become an expert. Experiment recklessly. Now, reckless is a dangerous word, but don't be afraid to throw caution to the wind and try new things and see what happens. And if it breaks, that's okay, because hopefully you've got automated testing. And if you've got automated testing, then you can feel free to break things whenever you want, because once the test passed, then good to go, ship it. And program a lot. Work with a suggested curriculum is a great starting point, but one of the things that I've realized, and there are a number of amazing resources for learning, so books and video courses. I have a video course. But I also know that the moment that I finished recording the videos for the introduction to CoreOS, CoreOS had released they release every day, and they had done so many releases that the content in my course really no longer applied. And I had to go back and start recording videos all over again. And I realized this isn't going to work. So a lot of this content, especially in the space that we're in, where in JavaScript world, things are moving crazy fast. They're too fast for me. I can't even keep track of all the things, let alone on the container space. You see new products, new platforms coming out every quarter, and it's hard to keep track. It's hard to learn them all. It's hard, let alone to master them all. So one of the things that I realized is I really wanted an open source platform, a learning sandbox. I wanted some place where I could go and experiment and try new things, pull in people from the community that maybe had different talents and different expertise and get them involved as well. And I started thinking, what would this ideal project be? And I'm currently exploring my career as a product manager, so let's look at this from a product point of view. Well, it's got to be entirely open source. We want to make sure that anybody can be involved, anybody can contribute, anybody can be a part of this. We'd like to solve a real problem. If it's just like some fake thing, then it's hard to make real-world trade-offs, right? The world that we're in, everything is about trade-offs. And so if you're building an actual system that you're actually going to deploy out somewhere, you suddenly have to start worrying about trade-offs. I pay the bills for this thing, so I have to be very careful about what we do and how we build it. Gets back to experimenting and trying new things. We need the sandbox where we're comfortable trying new things. And then we want to share what we learn. For me, I work at a company that I'm lucky I'm involved with a company that has an opportunity to interact with large-scale companies that are building and solving real hard problems. But if you're a new developer, an entry developer, or you're someone that's working at a firm that does not deal with this cloud space, but you want to get there, it's hard to learn the real-world pains and agonies of dealing with deploying to the cloud. What does that mean, and what are the problems and trade-offs? So being able to provide a mechanism to publish and document some of those best practices and lessons learned. And then finally, being supportive and inclusive to the community. Everyone should be welcome and should be able to be involved. And so after much soul searching and realizing before a webinar that I was supposed to do, I came up with the idea, the Internet Archive. So raise your hand if you've ever used the Internet Archive. OK, yeah, good. This should be good. So from an engineering point of view, the Internet Archive is actually a fascinating project. There's been a couple of research papers put out. This is a 2009 paper on the architecture for the Internet Archive by Elliot Jaffe and Scott Kirkpatrick out of the Hebrew University in Jerusalem. And just to give you a sense of the scale of what the actual proper Internet Archive is doing, in 2009, which they reference in this paper, I think it says it somewhere here, they delivered an average of 2.3 gigabytes per second of data to users. 2014, they were up to 15 petabytes of information. In 2016, they had 430 billion web pages archived, 5 billion new URLs in the last year. So this is a system that is at significant scale. And from an engineering perspective, when they first built this, back in '96 was when this first started, they had some very, very simple design goals, which for me, I love. They wanted to make sure that they only use commodity equipment. So they actually run 3 of their own data centers, which maybe I don't like running my own data center, but if they can do it, great. The system should not rely on commercial software. So they're either relying on entirely open source or they're writing their own open source tools to build out their system. The system should not require a PhD degree to implement or maintain. I don't have a PhD. And I've actually went in the last month or two, been reading some of their source code and trying to understand what it is they're doing. And it's actually readable. And some of the really cool things that they've done, one of the things that they've done is they built their own file system and their own file format. They don't have a database in the traditional form. They have a flat file structure, and that's where they do it. And actually, if you read some of the papers about like Google's file storage system and some of the other cloud providers, there's actually a lot of similarities between what they've done at Wayback Machine and some of the other providers that are doing now, which I think is fascinating, that years ago, it's the same paradigms. And the system should be as simple as possible, and it really is a system that it's simple. But there are some downsides. This is some old software. The original code was written in 1996. And it's old. In 2005, they went and wrote a new version. If you go to the Wayback Machine today, you're seeing that. It's a Java-based Wayback Machine. It provides complete backwards compatibility to their old file system, but does, in theory, enable faster development for user-facing features, which is great. And for me, this project is an interesting one. One, it's tractable. It's easy to explain. And it's something that you're going to deploy that you can deploy to a cloud. And you actually could build this. And that's exactly what we did. We created the lazy Internet Archive, or Wayback Machine. Now, I want to be very clear that this is not production ready. This is not an attempt to duplicate the Internet Archive. They have a staff with tons of money, and they're building, and like they are actually collecting all the real data. So this is a hobby project to experiment. I just want to throw that out there. Also, that makes me feel better because I'm always embarrassed whenever I ship code. So I'm embarrassed of this, but I'm happy to share it with you today. So the intent was to create a multi-tier, cloud-native implementation of the Wayback Machine. And if you sort of put on your design hat, if you were to build it today using the technologies we have, what might you pick? Why? What would it look like? And we've got a catchy name. It's Cloudy Time Machine. And in fact, you can go to cloudytimemachine.com right now and pull up our implementation. It's entirely open source. So it's all on GitHub. Everything is on GitHub. All the CI/CD is all, we're using Circle CI as our CI/CD, so you can go see all the builds. Every time we push out changes, you can see all of that. And let's go ahead and take a look at what that looks like. Oh, can I come over here? Here it is in all its glory. So I'm a huge fan of XKCD. So we can just query, and there's today's comic. We can take a look at election results, or the CNN page, which, if you scroll back in time, is like, it's all election stuff. So yeah, that's Cloudy Time Machine. We can see the live stream of all the things that have happened. It all updates dynamically in real time. All right. So that's Cloudy Time Machine. So what does it look like? Well, today's implementation, and I say today, I probably will change it later this afternoon in some way. Right now, we've got a web front end that is built on React and Webpack. Eric Hull, where's Eric? Eric's been working with me on this for a while. If you're looking for a front-end developer, he's awesome. Check him out. We have a public-facing REST API. It's all documented using Swagger. I'm heavily involved in Node.js, so of course it's all Node.js. This is actually a great example of something that you can use Node for, but I'll get back to some of the things that we're looking at for languages. We use message queues for our internal APIs. So we want to have a streaming system. We want to be able to scale easily, so we rolled out a message queue system. And we are 100% containerized. So we went, all right, let's do this. And we'll talk more about containerization. So Docker, and we're running this in Kubernetes. We're using Google's container engine as our container platform. Now, we did take some shortcuts, and I say shortcuts gently, basically meaning we're trying to build how you might today. So we're actually leveraging, in this case, Google's cloud data store for storing the actual images that we take. We might want to build our own system. We might want to build adapters for different cloud providers. I'll talk about that in a bit. We are leveraging RethinkDB for streaming APIs and powering the REST API. And obviously, I mentioned CI/CD using CircleCI. So just high-level architecture, we have Google's global load balancer at the top. We've got a tier of Nginx proxy and caches that handle routing within our services. We have a front-end single-page app that's React. I think it's served up by Nginx. Is that correct, Eric? It's Nginx? Yeah, it's Nginx. We have a series of API microservices that all scale horizontally. Those are backed by RethinkDB, which stores the metadata about all the images that we've captured. When an incoming request comes in, when you make a query, that gets sent off to a job queue. Currently using Redis. That's going away very, very soon. And then we have a pool of workers that actually are using Phantom.js to capture the screenshot, upload that to the Google file store, and then pass that information back to the API services, which then can feed it into the RethinkDB. And this is all multi-AZ, so trying to follow best practices of if something goes wrong in Google, in one of their AZs, we can automatically load balance between all those things. So what have we learned from this? Well, a lot. I've been using this as not only a sandbox for experimenting with new things for myself. Eric's been learning everything and having fun doing it. And there's a couple other people that I work with at NodeSource that are also involved with the project, and we're using it to experiment with some things on the Node side. I'm also using it for trying to understand better tooling and better systems to actually work, especially with Kubernetes. I do a lot of work with Kubernetes in the Docker ecosystem. And it's a great system, but there's definitely some improvements, and we'll talk about that. But one thing that is very true is that it's so much fun to have this sandbox, to just throw out new things and try things. And if it fails, so what? We have a beta infrastructure. We have beta.cloudytimemachine, and we have the official Cloudy Time Machine. So we have this basically a staging environment, but it's public. Kubernetes is definitely great for developers. When I did this CoreOS video tutorial series, actually I built it was a startup that I was working for, and Kubernetes didn't exist yet. And we built what I like to call a Hackinettes. It was a really terrible, terrible system that looked and felt like Kubernetes, but wasn't nearly as elegant and streamlined. Kubernetes as a platform really does enable developers to own that lifecycle and be able to debug and introspect what your applications are doing at scale and be able to deal with scaling problems. Another thing that I've pulled from NodeSource that we do very heavily at NodeSource is having design docs. So if we're working on a new feature, a new capability, we write up a design doc. What do we think? What are the business goals? What are the technology goals or limitations? What are we looking at? And then we have a discussion. What should we do? What are the different alternatives? And sometimes we come to the conclusion that we don't know enough about, maybe we don't know enough about the business cases, and then I have to go talk to customers. But sometimes we don't know enough about the technical systems, and we have to go do 1 or 2 proof of concepts. Once we learn from that, that can feed back into the design doc, which then drives the official implementation. Ship early and ship often. Have those tests, have that infrastructure. The moment you can roll out something, even if it's disabled behind a feature flag, you can start to see how that might have ripple effects in the rest of your infrastructure. Another thing that I care very much about is that as a developer, I like to think about my applications or processes. I don't like to think about virtual machines. Even if it's one app to virtual machine, I know that that's sort of a waste. Like, I think about processes as an application developer. And I'm on that spectrum earlier, like, I am definitely way on the developer side than the ops side. But I like to be in that midpoint. But I come from a developer perspective. And so I like the fact that with a container-based ecosystem, my applications, which scale on a per app basis, my containers scale on a per container basis, and they are a one-to-one mapping. So for me as an application developer, I can reason about containers when it comes to scaling and building out my infrastructure. Another aspect that I've been burned a couple of times, relying on cloud providers to be up and functioning when I need to do a deploy or if I need to scale my application. So in virtualized environments, if Amazon or Google doesn't have enough capacity in the region that you need to be bringing up machines in, you can't do your deploy if you're VM-based. With containers, you're independent of your cloud provider. Assuming you're not scaling beyond what you currently have in terms of your virtual machine infrastructure, containers allow you to scale up your front end. So presumably, like, Twitter's blowing up and everybody is using this site, so probably we should be scaling up our front end to handle that load. And we could. I know that we're not blowing up like that, but that's okay. Microservices definitely shift complexity around. So there's microservices, this buzzword, oh, microservices, oh, it's so great. And as a developer, it can be nice to really shrink down the scope of work that you have to worry about and think about in reason at any one time. But the reality is, if you're looking at microservices from an organizational point of view, all it's doing is just shifting responsibility around. It's shifting it out of the application developer mindset when they're building that app, and it's pushing it to infrastructure. So how do we do logging or distributed tracing? How do we do debugging, remote debugging? How do we deal with versioning of different microservices? So it doesn't resolve it, but it can enable some faster innovation. I certainly do if you've got the rest of the tooling around it. Finally, documenting and versioning streaming APIs is remarkably difficult. Swagger is an excellent tool to develop and document REST APIs, but there is a notable lack of good tooling for documenting streaming or message bus APIs. And that's something that I'm starting to think about and starting to deal with. Now, some of the things that we have built, we've noticed that containerizing stateful services is still hard. For any of you here who has worked with Docker or worked with Rocket or any of the container systems, in general, most of them still say, don't put your database into a container. Just don't. And that's because some of the tooling around that is not there. It's getting better. It's getting a lot better. I do a lot of work with RethinkDB, and I have a RethinkDB Kubernetes cluster that I've heard that a number of companies are actually now running this in production. When I first found out, that terrified me to death. And I'm in the process of trying to get this merged into the Kubernetes upstream as like a de facto example. It's okay to have opinions. That's something Angelina puts out if you go watch her talk after today or tonight. One of the things that she says is it's okay to have opinions. And in deployment in systems like working with Kubernetes and automated deploys, you're going to have to write some tooling. You're going to have to write some software to really make it all work, to sort of glue it all together. And that's okay. And it's okay to have an opinion and solve the problem you need to solve. And so something that we've been working on is something called K8s, or Kubernetes scripts, which sort of is a declarative syntax for deploying and managing an application. So like in a Node.JS world, you have your package JSON in your repo that sort of says, here's what we need to install to have a running app. There is a Kubernetes scripts sort of config file that describes which deployments and which secrets and which config maps need to be deployed out at any given deploy. So what's next? Well, more design docs. I actually have a backlog of design docs, and I have another contributor that has got a design doc that they're sitting on. And also tests, right? There's never enough tests. People here in the DevOps world, you should be loving tests. They make your life, you can sleep at night if you know you've got tests. We don't have enough tests, and that keeps me up at night. We're working on something, what we call ephemeral environments for PR testing. So every time there's a new PR to a specific service, we want to be able to spin up a whole new namespace in our cluster just for that PR that has the current production of every other service, plus the PR is the PR for the one service that you've made changes to. So you can independently test just that service that you've made changes to across the rest of your infrastructure. And I'm hoping that we'll have that out in the next month or two. Language agnostic. So the first prototype, this is an MVP of the system. We went with Node. That's what the handful of us that were starting this new Node. But we've got a Java developer who wants to get involved. I would like to learn Go, so I'm looking to find some opportunities to work with Go. And unfortunately, the message bus that we went with it's based on Redis. Redis, of course, is multi-platform, but the message library that we're using that builds on top of Redis is Node specific, and there are no other versions for other languages. So the lesson learned here is if you're going to pick a message bus system, you should probably make sure that it supports multiple languages if you're ever going to live in a polyglot world where you have developers that need to work with different languages. So we're probably going to replace Redis with Nats.io, but of course this is going to go through a design doc system first. So we can look at things like Kafka and RabbitMQ and some of the more traditional messaging systems. Cloud agnostic file store. Right now we rely 100% on Google's file store. And the original Cloudy Time Machine made it very clear that they don't want to rely on any specific provider or any closed source solution. So we either need to write our own, which we could, or probably might make more sense to write an adapter that can work with S3, it can work with Google, can handle the different cloud providers. And in fact, that exists as a Node module, but we need to find out if maybe some other libraries support that. Something we're still struggling with is how to document and version our streaming APIs. This is something that I mentioned this earlier. Swagger is great at that. I'm yet to find something that really works for streaming APIs. So if anybody here, and I know there's people here that know way more than I do about a lot of this stuff, if you know a streaming API documentation system, come find me afterwards. I want to know, I want to talk. I'm looking basically Swagger for streaming APIs or message bus APIs. That's what I'm looking for. That's what I want to find. We're also looking to make it easier to bring in new applications. We have new developers that are coming on board that want to be able to bring up their infrastructure. They want to roll out a Java-based version of any one of the specific components, or they want to add a new feature, a whole new feature that might be a new service. We need an easy way to get them on board and get them up and running. Really, it should be just like one click, and it's like, boom, here's a new GitHub repo that's got a Circle CI hooked up, that's got all the scripts set up, it's got all the permissions, and they're ready to go, and they're off and running. They pick their language, containers are built, they just do a git push, and it ships. That's where we want to be. And obviously, we're looking to grow and bring more people on. So if you have skills or you are interested in learning and playing with some of this, we'd love to have you get involved. Come find me, come find Eric right there. We're happy to talk more about the project. I do have a whole pile of resources here. I like to make sure that I quote. There's a lot of research on this space, and it's been fun researching this. Again, I want to thank Eric. Eric's been my front-end person because I haven't spent enough time in my life really mastering front-end development. In fact, I haven't spent any time at all. And so if I have to go touch CSS, I cry a little bit. That's how it is. And with that, thank you very much.
This is really interesting. Thanks, Ross. I'm curious when you're trying to decide how to do like a cloud agnostic file store, how are you going to deal with all of the ways all the public clouds like to charge you for moving data in and out of them? Like, is there something that you can do where you're mirroring the data but maybe not transferring quite as much of it? I'm just not sure exactly, or maybe something more cloud agnostic but keeping it mostly within one cloud and just using something that isn't their special sauce. I'm wondering how you keep those costs down for a hobby project.
Thankfully, there's not a ton of traffic yet, so that makes this easier. I think right now we've got, I checked maybe 2 weeks ago, and we had maybe 7,000 snapshots taken, and each snapshot's less than a megabyte. So, and the cost of file storage is really cheap. But you're right, network bandwidth tends to be one of the more expensive costs. And I don't have a magic answer. I'd love to have a conversation with you in a design doc about how we might solve that problem. It's hard. I mean, these are real engineering problems that I'm dealing with as a side project, as a learning experience. And I'm sure in the next month or two, I will have to start caring more about the costs, and then we're going to go figure out how to optimize that.
Hi, Ross. Great talk. Thank you. You talked a little bit briefly about Kube and why that was interesting. Is that only because GKE makes it go away, or is there something interesting about Kube as related to Swarm or Mesos or something that you liked it better?
You're asking why, as a developer, I prefer Kube versus
what
some of the
is
other
it that
things?
makes it more fun for you to use as a developer?
Yeah, so I think there's a balancing game here. So there's Kubernetes, there's obviously Docker Swarm's implementation. Join has got Triton. There's Mesos, Docker Swarm, Mesos, Kubernetes, and there's a couple other cloud providers got their own things. Each of them have got their own strengths, and so you got to find the platform that really solves your business or your technical problems. Nomad is the other one from HashiCorp. Nomad is, I really like Nomad, but it's very much a build your own toolkit. And so if you've got an organization that has enough staff and enough people to build out that, and you've got the expertise that knows how to build those things, then you're going to be able to build the most customized cloud toolkit for yourselves. And Docker Swarm is sort of that way too, where you still have to write a lot of stuff to really make it production ready, but if you've got the staff and the expertise to do that, then that's okay. For me, in most of the organizations that I work with or companies that I'm helping out with, a lot of them don't have that expertise. They are coming from where we've just got 5 VMs and that's our app, and we log in and we do a git pull and run npm install, and that's our deployment process. And so for those companies, they don't necessarily have the expertise in how to build some of these things. And there certainly are design things that Google has put into Kubernetes that are way over-engineered for those people that have 5 VMs. It's totally true. And there's a lot of language and sort of verbs you have to learn and nouns you have to learn to understand how things work. But the more that I've worked with Kubernetes, the more I realize that smarter people than I have figured out the problems. And it's like, oh, I need to find a way to inspect a pod and actually get some network traffic from it. And it's like, oh crap, I have to go build this thing that's going to be able to grab and connect to the socket. I need to write another container, and then I go read the Kubernetes docs, and it has port forwarding for any pod. And it's things like that that really have made my life as a developer easy. Certainly running Kubernetes as, if you're the ops team that is in charge of infrastructure, and you're not in Google Container Engine, there is definitely work to get Kubernetes up and running. It's less bad than OpenStack, in my opinion, but it's still work, and it's still responsibility. It's code that you have to own and manage. But as a developer, there are so many things that come out of the box that make your life easier. And if you're working with a company that might have a PaaS, if you have customers that or you work with things like Heroku, that maybe you've outgrown that sandbox of that PaaS and you need some of the more flexibility in the custom infrastructure, there are PaaS systems that run on top of Kubernetes. So if you have business units that need a PaaS, run the PaaS on Kubernetes, and those business units or those teams can just be happy doing git push to Kubernetes and it just deploys. But if you've got teams that need more control, they can drop down to the Kubernetes layer. So those are the reasons that I like it as a developer.
I suspect Ross would love to talk to you more about this in the hallway. Or an open space. This is an excellent topic for an open space. All right, it's noon. We gotta start thinking about lunchtime. Thank you, Ross. Let's have a hand.